Hi everyone, welcome to the Stage Modeling webinar. It's National Best Friends Day, so go ahead and grab a friend or a coworker and let's get ready to learn together. We are so excited for this event because we've had so much interest in this topic specifically, and we can't wait to give you more insight about stage modeling and more. My name is Karina and I'll be one of your hosts today, as well as your primary contact for chatting with behind the scenes. Please note that I'll be posting some polls throughout the event so you can get interactive with us. And if you have any questions, please feel free to submit those in the Q&A tab at any time throughout this event. Our second host today is, and most importantly, Swoosh's #1 CAD expert, Michael Pinto. Since 1999, he's been working with CAD features such as 2D and 3D modeling that leverage designs within NX. And along with this long streak of expertise, Swoosh Technologies has over 185 years of combined technical experience to help our customers and the NX community get solutions that they need to solve their trickiest problems. The agenda for our event today includes what is stage modeling, an overview of stage modeling roles in manufacturing, the stage modeling user experience, which kind of breaks down into a few different parts as you'll see shown here soon, reuse of MBD and PMI to author and execute user-defined roles, consumption of stage modeling information in production and the reuse of that data, and then licensing and packaging details as well. Before heading into the live webinar, I want to provide you all with some exciting updates that might interest you as an NX user. So Swoosh offers an abundance of NX classes either on-site or virtually, along with plentiful events such as NX University, which by the way is coming back soon, and webinars, blogs, and more. With these resources at your fingertips, you and your team have the opportunity to utilize new skills within your design and manufacturing processes on the shop floor as well. As mentioned, our crowd favorite event, NX University, is coming back in the late summer and fall of 2022. Get ready to join our team for a free full day of NX presentations and hands-on demonstrations, showcasing Siemens software updates, new features, and topics voted on by previous NXU 2021 attendees. We hope to see you in one of 7 cities this fall, and you can register by going to www.nxuniversity.com. Now let's take a quick sneak peek so you all can see what you have up for grabs. We are so excited to get back with you later this year to show you the latest and greatest in NX. If you would like to register, just visit www.nxuniversity.com. Lastly, and once again, please don't forget to submit any questions you might have in the Q&A tab, and we'll get to those at the very end of this event. Now I'd like to turn it over to our NX CAD expert, Michael, as he dives deeper into stage modeling.
All right, thank you, Karina, for that nice introduction. Welcome, everybody. Thank you for joining us this afternoon for our NX stage modeling webinar. We appreciate everybody's time, and we hope to share some new functionality with the software that is NX stage modeling. So without further ado, we'll go ahead and continue and get going here. A little bit about myself, a little background here. My name is Michael Pinto. I'm an application engineer with Swoosh Technologies. My contact information is shown down below my name, so if you need to reach out after the session has concluded, or whenever you would like to reach out, you can go ahead and email me at that address. So I have over 23 years of experience designing products for aerospace industry and consumer goods for various companies, including Pratt & Whitney and Nike. NX areas of expertise: I specialize in 3D modeling, advanced surfacing, freeform modeling, assemblies, drafting, model-based definition, as well as many other areas of the software. So today we'll go ahead and cover the stage modeling topic. That's why we're all here today. So we're going to take a look at NX stage modeling application, and we're going to create and modify parts to represent the different stages of a model in the manufacturing process. The benefits here: using stage modeling inside of NX is going to allow the user to streamline their manufacturing processes by using existing CAD models at the various design stages and reuse the information from the model to quickly create parts that will represent the design at the various stages of manufacturing. Stage modeling also allows for the quick reuse of the embedded model-based definition and PMI to add it to the other manufacturing stages or the different part files that are generated at each stage of manufacturing here. All right, here's a quick overview of the items we're going to be discussing here. Process automation, definition, and management of the stage models. Now, item number one, the first thing we'll look at here is the stage model definition, creation, and management of your stage models. Our next item we'll look at is model-based definition of the stage models. That is applying your PMI or your model-based definition to the different models. We're using that information at the various different stages as you create the additional stages here. Next topic we'll look at is consumption of the stage models. How do we reuse this data? So I've created my different stages of manufacturing for that part, and I want to go ahead and reuse that information and pass that off to the CMM inspection, CNC, CAM operations, have tool paths generated as well as the inspection paths generated downstream, reusing all of my stage model definition. And then finally, we'll talk about the licensing, different licensing options, and how you can go ahead and look at your licensing that you currently have and see if you currently have the capability to use stage modeling. If not, I will present a couple of options for you when we get to the flexible licensing section of the discussion here today. Quick overview of the stage model's role in manufacturing. Where does stage modeling and this process live inside the manufacturing process or the design process? If you look at the diagram here, you can see the stage model creation process highlighted in orange there. When you create these different stages, these staged models or different stages of manufacturing can be utilized for process planning, setting up and building work instructions. You can also go ahead and reuse that stage model definition and send that down to your other operations, such as machining, inspection, line optimization, and reuse that information to start your fixture design processes as well. So this is how or where the stage modeling creation process lives within the entire design process here. All right, so what is the stage modeling experience like inside of the NX software? Stage modeling is its own application inside of the NX software. You'll enter the stage modeling application when you begin creating your different stages here. The interface is a simple interface to utilize. You will notice on the left-hand side, you'll see what looks like very similar to the part navigator, but this is the stage model navigator. With the Stage Model Navigator, this is going to allow you to quickly build out your different stages, edit the properties, change the name, add different instruction sets, apply your PMI, and all your rule-based information will be applied inside of the Stage Model Navigator here. So you can quickly access the different features inside each stage and activate a different stage very quickly by clicking on the bubble there. Once that bubble is shaded with the green, that is the active stage that you're currently working on. So Stage Model Navigator is going to allow you to track content of all the stages in a single navigation tool. Very easy to use and navigate that tool. So if you're familiar with the Part Navigator, Assembly Navigator, it's the same type of scenario. It'll be in that pane over on the left-hand side of your display, and you can quickly edit and go back and forth between the different stages here. All of your standard right mouse button click or MB3 capabilities are available to access and edit the content in the actual Stage Model Navigator, and the Stage Model Navigator and navigation of all the stages and direct actions like activating a stage can be done inside the Stage Model Navigator as well. All right, so let's talk about the stage model definition, creation, and management discussion here. So the stage modeling application allows for rapid definition of the different stage models through modification and/or creation approaches here. Interactive stage model set creation. Very easy to add a stage, delete a stage, etc. here. If you start out with 4 stages and you decide you need to add a 5th stage, it's very easy to go ahead and do that and add an additional stage to the overall stages here. We're also leveraging modeling capabilities to define geometric shapes of the stage models. We can copy geometry with associative linking, utilizing synchronous technology, etc. And you'll be able to see in the demonstration how easy it is to accomplish this by linking or wave linking geometry from one stage into the next stage and making modifications to that geometry at that stage to quickly remove or modify the material on the part that is required at that stage. So this eliminates many manual modeling methods to complete the stage model, resulting in greater productivity improvements here. So a quick demo here, and we'll take a look at the first type of utilization of stage modeling. So in this demonstration, we're going to be taking a look at a top-down approach with our model. So here you can see we have a cover piece here, or cover part. And we have a variety of different slots, holes, or openings that are machined into that part. And you can see there is some PMI or model-based definition that has been applied to this part. So we're going to go into the application, stage modeling. Once we open up the stage modeling application, we're going to begin to create some stages here and define the geometry at each stage for the manufacturing process. So once you designate your number of stages here, in this case we have 6, we can go ahead and give a name to the process or the stage. As you can see in the Stage Model Navigator, there's our 6 stages. The production part, which is represented in the right-hand pane there, we're going to link that geometry into our first stage. And once we link that in, we can now activate that stage. Right-click on the stage inside the Stage Model Navigator, change the name properties here so we can give this a descriptive name for that stage, and then we can go ahead and modify a description here so we can more easily communicate to another user what's taking place at this stage with that description. So in this case, we're going to be describing on this stage, we're going to be milling out some different pockets. Now we're going to go ahead and start to add some definition here. And when we add the definition, what we're doing here is we're basically telling another user what is being machined at this stage. So you can do that very quickly using the color group up there. We can group some faces and we can apply a color to those faces. So a user opens up this stage, it can very clearly see what is being machined at this stage. Now we're going to go ahead and use or reuse some PMI from the top level or the final production part. So we can click that additional PMI and we can reuse that downstream in another stage here. As you can see, when you click that or select that feature control frame, you can see it highlights in the other stage. Once you start to reuse the PMI between the different stages, you can see there's a direct correlation or relationship at each level or each stage. So if I were to modify the PMI at one stage, it's going to update in the other stage accordingly. We have that direct relationship that we just created here. Now, this is going to save you time and efforts by being able to reuse this PMI between the different stages, so you don't have to recreate that at every stage. When you're ready to create or activate the next stage, go ahead and click on the green bubble over there and shade that in. Once you activate that as the active stage, we can go back in and begin wavelinking the geometry from the previous stage downstream into the next stage that we're beginning to work on here. Now we're actually going to go ahead and utilize some synchronous technology to delete some faces at this stage and quickly remove those out of the part, because those parts or those faces would not be milled out at this stage. So we're going to go ahead and add that material back by deleting those features off of the part. Now we can go ahead and do the same thing we did in the previous stage. We can go ahead and group the face, change the color to green, giving the indication that this is what's going to be milled out at this stage. And of course, we can go ahead and reuse our PMI once again if we need to do that. First, we'll go ahead and add some descriptive names here. So for the name, describing this milling operation. So we're going to mill that large top opening inside the part. Once we complete that, you can see the name has adjusted or updated, and now we can go ahead and reuse PMI from that final production stage. So we will select the related PMI, and you can see immediately it is added to our new stage. All right, so we'll go ahead and save that part and then move on to the next stage. Now you'll notice when we do create a new stage, we can very easily show all the different stages on the same window here inside the graphics display. So we can use that multi-window technology inside the software to help us present all of our different stages at the same time on our monitor. Now, of course, you want a larger monitor. If you're working with a laptop, it might be a little bit difficult as you start to open up more and more windows here. The windows do get a little bit smaller, so I do recommend if you start to open up multiple windows, it would probably be best suited for a larger display. All right, so we're going to go ahead and mill out this portion of the part this time. So everything that we're highlighting here, you can see this is going to communicate to the person that opens up this file for the machining operation that these are the features being machined at this stage. Like you saw in the previous stages, we added that green color, and that gives the indication of what's being actually machined at this stage. We're going to reuse some additional PMI from our final production part and add that to the part. Now you can see flashing forward here, we do have a series of different stages. When we do get towards the first stage in the operation, you can see we can easily use some synchronous technology, remove some of those radiuses off of the edges. So we're back to some sharp edges. And now we can actually add some tooling stock by adding or using synchronous technology to offset some faces here and add some additional tooling stock at this stage. So the utilization of synchronous technology is going to definitely make your job much easier, and you can quickly add the tooling stock to that stage. Now we can go ahead and add some additional coloring here to the faces to let the person that opens up this part file, let them know and communicate to them this is what's being machined at that stage. All right, so that was a quick demonstration of utilizing a top-down approach here with stage modeling. What's nice about stage modeling, we can also utilize a hybrid design approach here. So we can go ahead and utilize stage modeling approach starting from the completed production part, as cast part, or any step in between here. The rapid definition of stage models through modification or creation approaches. And then we can interactively utilize the stage models or model set creation and add a stage, delete a stage, etc. here in between from the as cast part all the way back to the production part. What's nice about this is with the production file, we might have some tooling bodies in there we can take advantage of, and we can go ahead and use those tooling bodies in between the different stages here. So this is going to eliminate many manual modeling methods to complete the stage models, resulting in greater productivity improvements here for the user. So in this next demonstration, we will be utilizing the hybrid approach here. On the left-hand side, you will see we have the crank as cast here. So our crank part, this is the as cast representation. On the right-hand side, we have as designed with the tool bodies inside this part file. So in this demonstration, you will see the reutilization of the tool bodies from the final production part file, and we can use those in between the different stages here to help us to machine away some features on those stages. So of course, we're going to jump into application stage modeling here. We'll go ahead and introduce our number of stages. So we're going to choose the crank as cast part first here, and we're going to do one stage to start with, select OK, and then begin creating or editing that stage. So you can see this is operation 10. Give ourselves a description here. So in this case, we'll be doing some flange machining at this operation level. And of course, taking advantage of that multi-window capability, we can go ahead and show the as cast part and the final production part, as well as the new stage we just created. We're linking in the as cast part. And now we're going to take advantage of the as designed part with the tool bodies in it, and we're going to show the actual tool bodies to machine away the two end surfaces there. So we're linking those bodies into the as cast part, and now we're going to go ahead and subtract those from the as cast body and remove the material. So as you can see, it's very easy to start out with the as cast part and also have the final production part, and now we can do the in-between stages here and utilize different solid bodies or tooling bodies from the final production part and use those or reuse those bodies inside the different stages here to machine those that material away from those stages. As we continue, we add an additional stage here. So we're going to go ahead and link the as cast body from the previous stage with the two ends that have been machined. Go back to the final production part, and we're going to go ahead and turn on some additional tooling bodies here. We will go ahead and link those into our new stage and use those to subtract some material from that stage. So you can see the benefits of these capabilities of using or reuse of geometry from additional parts by wave linking those bodies into the additional stages. This is going to save you a lot of time. If you have the tooling bodies in one of your part files already, you can quickly link those into another stage, reuse that information, and quickly subtract that material away from that stage. And here we'll just go ahead and subtract those bodies, those tooling bodies, from that stage and finish that stage out. And of course, we could take advantage of the color, assigning some feature colors, and we assign some a blue color to those features so you can very easily see what's been machined at this stage. We can go in and customize the name here to operation 30, select OK, and we've completed our new stage. All right, so we'll create one more stage here, link the geometry from the previous stage into our new stage, and then we'll go ahead and link the geometry or tool bodies from the final production part into our brand new stage, and we'll be able to subtract that material away from the main body here or part. All right, and as you can see, it's very easy to reuse data from the parts. It doesn't matter if it's from the as cast part or from the finished production part. We've done a combination here with this hybrid approach. Started out with the as cast body, We also had the final production part, and we're building all the stages in between as demonstrated. Once you create those stages, we can take advantage of a comparison tool inside the software to compare one stage with another stage. This way, when we do the comparison, we can very easily see what has changed between the two stages here. So in the next demonstration, you will see this process as it's doing that on the part. All right, so we're going to do a quick comparison between a couple of stages here. We're going to go into analysis, compare body. Now we can go ahead and select one of the stages here. So pick the body in one stage, pick the body in the second stage you want to compare between. Select the compare button. It's going to open up a dedicated window. And we can go ahead and make that the focus here. So we can grab that tab and we can go ahead and make that a little bit larger to really focus on those two parts we're comparing here. As you can see, we have stage 1, stage 2, and over on the right-hand side, you can see the overlay between the two parts. With the overlay view, we can use the slider here to show the control or the sample and slide back and forth and see the difference between those two parts. So very easily, you can compare two different stages and see the differences between those stages. In this case, we're machining some material away, and we have some radiuses that were added on the edges there. All right, model-based definition of stage models. So we can capture manufacturing information on the 3D stage models here. We can reuse that information and we can build out these different rules and leverage these different rules to quickly apply the model-based definition to our different stages or our parts. So it's going to allow us to reuse the PMI to repurpose manufacturing information from the design parts with the associative links. Leverage NX model-based definition capabilities to author and execute user-defined rules on the stage models. And there are stage model-specific rules delivered out of the box. So Siemens has introduced this rule-based system. We can utilize this tool to build out these custom rules, but there are also some rules that have been provided from Siemens for the user. This allows for rapid definition of your stage models with captured manufacturing information, and it's going to lead to significant productivity gains here. So if you have a series of holes on a part and you want to create a rule that specs out a fit for those holes, you can very quickly create a rule, save that in the reuse library, and you can use that in the future. Grab that rule, drag it into the stage, and it's going to apply that rule to that part and quickly add your model-based definition based on that rule. So a quick demonstration of that process here. So we'll go into our reuse library, go into our logical rules, and navigate down to our staged models folder. Inside the staged models folder in this example, we do have a fit tolerance rule that we can go ahead and utilize for our part. In this case, we can build out or set our upper and lower tolerance, set our deviation in our grade. Then we can go ahead and select the surfaces inside the stage part, and we can apply the stage model rule to this part. And once we complete this operation, you'll see the software can recognize everything that was selected, and then we can select OK and apply that rule to that part. So you can see the software is automatically adding the definition based on the rule from our library. All right, once you create these different stages, the stage modeling information can be reused downstream. The consumption of your stage model data is reused very easily in other operations such as NXCAM, NXCMM, and Part Planner, etc. here. So you can invoke downstream application directly from the stage model, set up creation on stage models directly in NXCAM, NXCMM applications, and stage models can be exported for external applications as well. So this is going to help automate downstream manufacturing processes right through consumption of your stage models and the associated manufacturing information on those models. Once again, we get back to talking about saving time. being more efficient with your design process, and reusing the model data in other operations here. So in this demonstration, you'll notice how easy it is to reuse the stages and their associated model-based definition in downstream operations, such as CMM inspection programming in this case. So with our stage model open already, we can go into a File New, go into the Inspection tab, and it's going to reference the existing stage model that was already open in session. Once we do that, the software reads the information from the stage model, and you can see we can begin to link to the PMI and very quickly generate all the information for our CMM program. Once we do that, you can see our tolerances have been pulled from the part, the model-based definition, our different features have been pulled, as well as the inspection paths generated for those different features here. So this is going to save you a lot of time instead of having to manually create these paths and pull all that data into your CMM operation. The software automatically reads your information, your model-based definition on that stage, and it generates all of your different inspection paths for you here. So this can also be utilized with your CNC operations, and all your tool paths can be generated based on the information from the model-based definition here. So let's talk about our licensing and packaging here for your NX stage modeling. NX stage modeling is an add-on. This is an additional license. The capabilities will allow you to create those stage models, create the stage model definition. You get that entire user experience with the stage model navigator, as well as the PMI reuse capabilities and the derived stock. So you can derive stock and use that functionality as well. Our product name and price is NX Stage Modeling. This is also available with tokens. So if you have capability to utilize tokens, you can use those and take advantage of your tokens to use the stage modeling application. Prerequisites here, any NX or UG bundles containing gateway. This does require modeling, PMI, NX model-based definition to complete the workflow here. All right, so a quick summary of our benefits here. As you saw, it is very easy to use the stage modeling environment. It is suitable for manufacturing engineers. The definition, creation, and management of the stage models focused on improving your efficiency, and you can reuse that data very easily downstream in your CMM inspections, CNC operations, as well as other applications. You can also leverage the NX model-based definition in the stage models environment and drive rapid authoring of the downstream manufacturing information on your stage models. Additionally, stage models consumed directly in your downstream applications will help to automate the manufacturing processes as well. So as you can see, there are many great benefits to the stage modeling process here inside the software, and I thank you for watching the demonstration here. Once again, there's my contact information, and now I'll hand it back to Karina, and we will begin the Q&A session shortly here. So back to you, Karina.
Thank you so much, Michael. I hope everyone learned tons of new information from your demonstration today. Before heading into the Q&A section, I have a few more reminders for everyone if you can just stay tuned, please. As shown here, this is a list of NX classes taught by the very best specialists here at Swoosh. If you're interested in learning more, feel free to contact Michael himself, or you can also contact our training director, John McManus, by emailing him or visiting our class schedule on www.swooshtech.com. If you would like to stay updated with everything going on behind the scenes here at Swoosh, we do encourage you to please follow us by signing up for our newsletter within our website, following us on LinkedIn, and subscribing to our YouTube channel. We have new content put on here daily, and we'd love to share it with each and every one of you. Lastly, I would so like to thank each and every one of you again for joining us today, and we can't wait to see you again soon for our next upcoming event. Now feel free to stick around for Q&A. However, if you don't have any questions, we hope that you have a great rest of your week and enjoy the day, everybody. Bye. We'll see you next time.